All right.
Will you advance one slide so I can see if that's my presentation?
Yeah, we just put a,
You put a title on there.
yeah.
Okay, all right. Just wanted to
there's
make, okay. Oh, there's my baby.
Okay.
All right, thanks.
We're going to go ahead and get started. Give everybody a minute to have a seat. Can we have a seat so we can get started, please? Thank you. I know I'm in a room full of rebels here. Great.
Oh, that's you, Michelle. That's
Thanks
real
so
personal.
much. Yeah. So we're going to welcome Jane Lundquist. She's a professional engineer, motorcyclist, and statewide value engineering program manager, design division with the Texas Department of Transportation. And Margaret Fowler, associate transportation researcher with the Texas A&M Transportation Institute. You can read more about them in your program. Please join me in thanking Jane and Margaret for participating in our event today. And then at the end, we'll drop a survey in the chat, and we also have them at the back of the room if you'll fill that out so we can better plan our event for next year. And with that, we'll get started. I'm going to go over to the computer and start Jane's presentation. Jane, take it away.
All right, thank you. I hope you can hear me.
Yes.
All right, I'm Jane Lundquist. I have been working with TxDOT for 20 years plus. I have done reviews, design, research, specification, and TxDOT manual writing, and I have worked on planning activities, as well as being a motorcyclist since I was 17 years old. My very first ride on a motorcycle was a family friend who had an old red Cushman. I was about 4 years old. He let me stand on the floorboard and hang on to the handlebars, and I was hooked. So I had to wait till I could get my license and ride my own. I took a break from riding as I raised our 2 sons, and then I went to school to train for my life's next career as an engineer. When I got my first job after graduation, I told my family I was going to buy a motorcycle. And that's the one you see to the right there. I had just washed my baby blue, and it's a 98 Harley Davidson Dyna Lowrider. I made good on my promise, and I have used that motorcycle for some long road trips. I took them on my own, enjoyed the people along the way, women who are around my age. I'm an older adult, and they would stop and they had all kinds of questions because it was very interesting to see a woman riding a motorcycle, and here I was by myself. So with that, I'm going to move on to the next slide, please. Back in 2015, there was a Federal Highway Authorization Act called the FAST Act. And within that act, the Federal Highway Administration was authorized to reestablish the Motorcycle Advisory Council, which we call the MAC. The US DOT designated the Federal Highway Administration to study barrier design, road design, construction, maintenance, architecture, and implementation of intelligent transportation system technologies. I was one of 9 people from different backgrounds appointed to a 3-year term as a federal special government employee to the MAC. At the conclusion of the MAC, FHWA contracted TTI to investigate and conduct background research for infrastructure safety solutions with respect to the findings of the Motorcyclist Advisory Council. I have served as a stakeholder in this engagement group of professionals, and I continue to work on motorcycle safety issues. Next slide, please. The MAC topics that were raised and debated extensively, a lot of it had to do with ASHTA, which is the American Association of State Highway Transportation Officials, the design publications. For the most part, motorcycles have been not recognized as a vehicle class. And so we were very emphatic that this needed to change because we do have three manuals that are used quite extensively for designing our highways. One is the Manual for Assessing Safety Hardware, which is known as MASH. And this is important because we have motorcyclist barrier safety to consider. We also have a book that is the Geometric Design of Highways and Streets, commonly known as a Green Book, and that gives us all the geometric design criteria that we need for designing a roadway. Then we have the Roadside Design Guide. It does not address motorcycle roadside safety issues, so we want to make sure that we have some input into these publications because there needs to be greater awareness for designers. In some of the information that we received in these conversations, the roadway friction tests that were performed with automobile tires were not done with motorcycle tires, which have different profiles and pavement contact surface patches. So there's no existing single track vehicle testing at this time. Work zones are considered an area where there are multiple riding dangers. You got loose material, dust, flying debris, steel plates, which are like riding over glass, poor or no signage for motorcyclist hazards, no alternate routes for riders, pavement drop-offs, and groove pavement are big concerns with riders. Some of the concerns that we have with V2X technology and how motorcycles will be included were also in some of our conversations, and they were brought up in the previous presentation. Next slide, please. What is TxDOT doing for motorcycle safety? Well, we are doing several things. I'm going to, this is a list of the items that I will talk about briefly. We do research, design, and media campaigns. TxDOT a research project with contracted researchers to develop a retrofit design for guard fence system to enhance motorcycle safety. TxDOT is the lead organization for a national pool fund motorcycle study, which has been cleared by the Federal Highway Administration with commitments from state transportation agencies, Colorado, Illinois, Louisiana, Massachusetts, Utah. And that's for development and evaluation of roadside safety systems for motorcyclists. TTI has been contracted to do research for this pool fund effort. We do roadway pavements, roadway signage, and we are concerned with public service announcements, commitment to Vision Zero, and billboards. Next slide, please. TxDOT's research project, the development of a retrofit design for guard fence system to enhance motorcycle safety, is the example that I want to show in this diagram here was a collision that occurred, and it was an injury with the metal beam guard fence impact. At the bottom of the picture, there was a motorcycle. It hit a collision with a muffler. And this particular roadway is also what it's called a super elevated horizontal curve. And when I speak of a super elevated horizontal curve, it's a curve where you have the rotation of the surface of the highway. In this diagram here, the inside of that curve is lower than the outside of the curve. And that's to provide safety and comfort for the drivers that go along this roadway at speed. And it's a geometric calculation that we use. Anyway, we have the motorcyclist at the bottom there. They hit the muffler, and it causes the motorcycle to veer. It ejects the rider and the driver. There's a passenger on the back end, so there's the driver and there's the passenger. The motorcycle hits the guardrail. It ricochets off into an arc and it slides down the hill into the next lane. And since the motorcycle is going at, let's say, 70 miles an hour, so are the people. Well, the people go down there and they hit one of the beams. You know, you've got the wooden posts there. An arm was severed. The person who was the passenger goes tumbling down the road. And as they finally come to a stop further down the road, both have severe life-threatening injuries. And I believe in this case, there may have been fatalities. So this is a serious problem. We are trying to address it with some research and design. And I think if you go to the next slide, I'll show you the design. The original design that we looked at to try and mitigate these kind of barrier collisions and the dangers they present was to put a skirt on the post and a cap over the rail. And we thought this would help. As you see, when someone hits a post, it's almost like a knife. I mean, it's going to take fingers, arms, heads, legs, whatever. So we don't want anyone, hitting that post. We're trying to protect the riders if they are ejected from their motorcycle. So you can see in the diagram on the right that we have the cap, and then we also had a skirt underneath that block out. And what it looks like is what you see in that left photo. And the next, let me introduce this. This is the TTI testing facility. And out here we were doing upright rider cap rail test. And so if you can make that video go, just give it the start. As you can see, the rider was able to slide across the top without hitting the top of the posts. And they were not hitting the top of that metal beam, that W beam that's at the top there, the sharp edge. So let's go to the next slide and see it from a different angle. If you start the video. As you can see in this video, the rider is protected across the top as they slide across that cap. It keeps them from being cut by the metal beam guard fence itself. It is a violent collision with a metal beam guard fence, but the top of the cap, that worked and it passed its testing. Let me go to the next slide, please. We also did a sliding rider check because sometimes when someone's ejected from the motorcycle, they go sliding off on their own, the motorcycle goes in another direction. In the upright rider videos that you saw, the cap worked well and it met criteria that we were designing for. However, we have tried the sliding rider impact with that skirt panel, and we did not have satisfactory results. So we've had to go back to the drawing board and do new testing. we can go to the next slide. What we've done here is that we have left the cap in place because that seems to work. The W beam is that thing that looks like a 3 on the side there. That's the typical beam on a guard fence. But below, instead of putting that skirt up against the post, there is a Z bracket which will absorb the energy from the motorcycle or the rider from hitting it. So we feel that that is going to work better for us. We've had some issues with COVID protocols where we weren't able to do some of these tests, but they are increasing now. I think they're scheduling more, so we may have some better results coming up soon. We can go to the next slide, please. TxDOT is the lead organization for a National Pool Fund motorcycle study. As I introduced before, we have 5 other states that are joining with us. It's similar to the TxDOT research that we're doing, but we're using a cooperative approach to find safety solutions and up-to-date examination of best practices for motorcyclist roadside safety that may be used in other states. And we can share solutions and find ways to treat problems that we've had difficulty resolving. We will be trying to implement any of these designs into the MASH manual. If we go to the next slide, please. TxDOT is also working on trying to provide pavements at curves. Although this roadway is not in Texas, it looks like it'd be a daunting road to ride because you'd have left curves and right curves. But in anything where we have moisture in the shade, anytime you have moisture on the road, we have problems with friction that holds us, and we can't make our curves meet safety turning ability. So we are trying to review crash history and focus on design attention to the areas that may require better skid resistance and maintenance needs. We do have high surface friction materials that we do put on curves, and although it's not a blanket change for the whole state, we do focus on the areas where we've had issues and where we feel that it's beneficial. Next slide, please. This is a picture of what we know as a roadway skid test. It's a trailer. It's on the back of a truck. As it's towed down the roadway, there's a jet nozzle that feeds sprayers at the tires. And so the testing is done and measured so they can tell if there is reasonable friction safety on a curve. And if you notice, it's 2 wheels, it's not a single track, and we don't have any way to perform this, so we do reasonable safety simulation and use conservative values so that we can make sure that that curve will work safely for motorcyclists. This is something that we have brought to the attention of the Federal Highway Administration. Next slide, please. We are trying to improve signage, particularly at curves or anywhere that we have issues on the roadway. In a work zone where you see the orange signs, we do have signs that we can put up when we have problem areas. An excess oil, it might be an exit for a refinery, or we might have a lot of heavy vehicles that are going in and out of a driveway that may have an impact on the roadway safety. But we are trying to use signs to improve notice to the motorcyclists. Next slide. If you should be on a ride and you find a problem with a road, I know that we have wayfinding that is being tried and used to notify riders about issues. But to report a roadway problem and have it repaired, if you go to inside TxDOT and you select districts, find the district or the county, there's a selection there for the county where you found this problem and report it. I believe the email for the district engineer is there, but administration of that office will make sure that information is passed along to the appropriate area office so they can examine the issue and get it fixed. And we find that, we don't want to leave, if there's a pothole out there, we don't want to leave a hole on the road and have a hazard. So if you find something and you want to report, go directly to the website and speak to the people in the district. Next slide. TxDOT does public service announcements and advertisements to get drivers to look twice for motorcycles. Motorcycle training and personal safety equipment are the best way to protect your safety. And it's the responsibility not only for our own safety, but for those who ride with us. And there are things that this poster points out that we don't have a roof, we don't have a crumple zone or a seatbelt backup light. These are things that people need to understand about motorcycles. They're very vulnerable in the traffic, even though we have maneuverability, we can still get caught in a serious situation and we are not protected. Next slide. The Minnesota Department of Public Safety has had some of the most innovative, provocative posters over several years, and I've found them to be absolutely humorous. But they send out a real important message. And in the fine writing, if you can't read it, it says over 50% of those killed in motorcycle accidents had been drinking. So unless you're trying to impress people with a big funeral, don't drink and ride. So I thought that was it's an eye catcher. Get the next slide, please. Of course, we heard this morning from Letty Van Rossum about ending the streak here in Texas. Too many people have died on our highways and roadways, and we want to ask everyone to help TxDOT solve this problem. And I want to part with my saying here is to remember that safety is intentional. I thank you for your time. And next slide. I can take questions at my email address if you're interested in asking any more. I'm still involved with research at this time, so I hand it over to the next speaker. Thank you very much for your time.
Thanks, Jenny.
the deployment of connected and automated vehicles. I also have a background in human factors where I've observed driver trust in automation. And today, I'll be talking about some crossover on some of these applications to the motorcycle community. Next slide. Oh,
Just like, sorry. Okay.
so today, I'll be reviewing a project I was recently involved in to land me here today and what that included, as well as what ITS is and some key differences among the various applications. And then finally, what the potential impact of these applications could be to the motorcycling community. And finally, conclude with some results that emerged from our most recent study. Next slide. Next slide. So as Jane mentioned, the Motorcycle Advisory Council is responsible for providing infrastructure-based countermeasures. And this project is actually part of a series of projects. Like Jane mentioned, there is work done on geometric design as well as barrier design. But specifically, the project that I was involved in was focused on improving infrastructure in terms of connectivity and as well as advanced safety features included in motorcycles. So some of our primary research objectives in this project was really to understand what the current state of practice is, as well as knowledge and identify future areas of work through these project tasks on where connectivity could benefit the motorcycle community. Next slide. So we did this really through an extensive literature review, but also more importantly, obtained crucial feedback from various stakeholders where we hosted multiple focus group sessions with experienced riders, as well as key federal agency members from both FHWA and NISTA. And then finally, synthesize all of these to identify future areas of work on where connectivity could be beneficial. Next slide. So ITS, which also stands for Intelligent Transportation Systems, is really a broad term for various technological approaches on how to improve roadway safety. And the reason why I included this slide on today's presentation is really to make a distinct difference between connected vehicles and automated vehicles. Often these terms are used interchangeably, but just because you have a connected vehicle doesn't necessarily it will be automated and vice versa. So kind of going through these different terms, connectivity really refers to the communication between vehicles. This could be V2V, vehicle-to-vehicle communication, as communication, and then V to everything, which would be infrastructure and vehicles. But then automation, that's really just a term of a system capable of prevention, and it exists on a continuum. So you can have a task that is completely manual, level 0, no automation required, but then as well as a level 5, which is the system is fully capable of performing all the subtasks within that task. Or you can have meet in the middle and it be partially automated. Think of like intelligent or adaptive cruise control. System is capable of some tasks, but the human driver still needs to observe. And then finally, a term ARAS, which is Advanced Rider Assistance Systems. This emerged from our research as just similar to ADAS, which is Advanced Driver Assistance Systems. And it was really just equipment to support the motorcyclist in performing various riding functions to stay safe. So this could be adaptive headlights, ABS, CBS, forward collision warning, so on and so forth. But for this project, we are really trying to understand, from the federal side and for riders, what their thoughts and feelings are on both connectivity and ARAS specifically. But our findings, they could apply to automated vehicles. Next slide. So this is another illustration that emerged from our research, kind of just to denote how connectivity could enhance motorcycle safety. There are ARAS systems currently in place, but combining it with connectivity would create a broader vision of the roadway and provide more information to make better decisions on the system side and the rider. Next slide. So looking at the potential impact and, the reason why crashes and fatalities are very much overrepresented. Some have even said this is a global health problem. And about 3% of registered vehicles in the United States are motorcyclists, but yet they account for about 14% of fatalities. And this is even seen in comparing motorcyclists to drivers when you look at VMT rates. Next slide. So part of this problem we found through our research is that, and focus group sessions really, is that the margin of error for motorcycle riding is much less than of a passenger vehicle, and often this leads to both perception and execution errors. And one study even found that when comparing a motorcyclist and driver, often motorcyclists are experiencing sensory inputs by nearly 1.7-fold of their passenger vehicle. So this includes vibration, noise, climate, making it much more difficult to stay focused, but also puts a very big emphasis on having high situational awareness throughout riding. Next slide. So where connectivity comes into play is it's really that extra layer of safety. Starting with the first layer, most basic being your PPE, but having connectivity is providing maybe perhaps more separation between the motorcyclist and the roadway. And I think also my last slide might have been a little misleading, but there's also a lot of drivers that cause accidents with motorcyclists, and often about 70% of those are due to perception errors on the driver's end, so not seeing the motorcyclist. And having connectivity can not only increase the motorcyclist visibility by informing the driver that they're nearby, but then also informing of the motorcyclist of upcoming conditions so they can stay prepared. Next slide. So the Connected Motorcycle group, they are a collaboration between researchers, suppliers, manufacturers, where they're really trying to integrate connectivity into the motorcycling community. They have come out with system architecture and different applications on what connectivity in motorcycles could look like. And here are just 4 examples I pulled from their website, but they have plenty of various scenarios, but I thought these were some of the most compelling, which include left turn assist, intersection movement assist, as well as forward collision warning, and all. So our literature review really indicated that there's huge research gaps in really what the warning intervention and timing should look like in sending these messages to motorcyclists. Because although they could add a safety value, if they're too distracting, they either will not be used or could potentially cause more harm than good. But then also there's other design concerns in terms of the motorcycle's ability to lean and the fact that it sits low and having a small surface area of where antennas could be placed as well as sensors. But even if we were to drive in a world of just connected vehicles, how accurate would their detection be of motorcyclists? And then finally, you know, our group agreed that more comparative analysis needs to be conducted. What would yield the maximized safety benefit? Would it be having a world of just connected vehicles where motorcycles are excluded, but they still emit a signal to drivers to inform them they're on the roadway as well? Or would a mix of vehicles being connected, motorcycles and passenger vehicles, yield the maximized safety benefit? Next slide. So a listening session that we conducted included FHWA members and NISTA members. And throughout this discussion, we really wanted to understand what future work needs to be done in order to integrate connectivity into the motorcycle community. And we identified through this listening session 5 primary research focuses. Next slide. But looking at the top 3, this was one, assessing current machine vision systems and understanding if, as vehicles become more advanced, setting standards on their detection of motorcyclists, which kind of leads me into my next point, creating performance standards for connected and automated vehicles to include other users of the roadway to ensure that in all these scenarios, they are detecting most accurately. And then finally, rider trust. We could deploy this technology, but trusting and actually using the technology is a totally different story. And integrating into the community will take time and also perhaps a small learning curve. Next slide. So our focus group sessions, we hosted 2 focus group sessions where majority of riders, were educators, instructors, and everyone had a minimum of 6 years riding experience. And the question that we brought to the focus group was really, what are the foreseen benefits in connectivity, as well as what are your concerns in this technology? Because again, going back to rider trust, just because it's deployed, it perhaps might not be used. Next slide. So some of the benefits that were mentioned in these focus groups was one, reaction times. Being able to prepare for scenarios such as maintenance up ahead, construction, pavement conditions. More often than not, signs could be missing or the appropriate signage. And then as well as improving novice rider confidence, using these features more as a tool to improve skill and become more comfortable in all sorts of riding scenarios before going completely manual. But this was more with the caveat that these focus group members really made sure to make the point that they would want these systems to be able to be turned on and turned off. And then finally, also use these systems as a preventative safety measure. Some scenarios are not necessarily predictable, so having connectivity, again, could be that added layer of safety. Next slide. So some of the primary concerns, though, from these focus groups was really riders being over-reliant on this technology to the point where they wouldn't develop the appropriate skills to be an expert rider. Situational awareness is a big factor in being a successful rider. And if folks were to become over-reliant on this technology, who's to say that they would ever get the true manual experience, especially if in scenarios where this could malfunction, how would riders respond then? And once again, maybe put them in more harm's way than add safety to their riding. But then also, like we mentioned earlier, another concern was warning display distractions. But then also, they brought up the point of rider interaction with autonomous features. If there were to be any jerky movements or if the rider's choice was not aligned with the automated feature, would the rider respond in such a way that would make them less stable and potentially user acceptance, concern that the community may reject this technology because, as they explain, writing is about being free, and having this technology may take away from that. Next slide. So in combination through literature and listening sessions and the focus group, the primary research areas we found to integrate connectivity into the community was really focusing on rider trust, but then also warning interactions, modes, timings, etc. And then these were some other future research areas that emerged through synthesizing all these findings, using connectivity to become more visible, to provide warnings of pavement conditions, construction zones, et cetera. And even brought up the application of using connectivity for both lane splitting and filtering to warn surrounding vehicles of this maneuver. Next slide. Email, I'd be happy to speak to you personally after this, but thank you all for your time.
Today. It is now lunchtime. All right. So we are going to be lunch buffet style in the room right there. But before you go, I have two pieces of information that you're going to want to know. One is the reminder that you know about. Please do your evaluation. There's forms at the back of the room, and there's also a QR code in the back of your program. And also there's an opportunity to ride this afternoon. If you have your bike and your protective equipment, there will be DPS motor officers that are going to be out there and available to help guide you through invasive maneuvers. So please feel free to do that after lunch. So lunch right now, room to the left, buffet style. And there's three sessions in the afternoon, one of which, if you have your bike in gear, you can ride.
Sunny breakfast. Okay. And we caught up on time.
Good. Sorry, now I know. Get on the thing.